Hello, and welcome to another screencast for mTree. So today we'll be discussing the voluntary contribution mechanism project that you'll be working on over the next few days. And it'll be similar to previous screencasts, but the focus will be on providing sufficient background for you to look through the example code provided and add appropriate directive handlers. So the first thing we'll look at is the voluntary contribution mechanism. I believe you should have already seen this slide. So obviously there'll be an environment, an agent, and an institution. The environment will have a number of agents that it selects. Each agent will have a certain endowment, which will be uniform across the agents. And then they will also be able to provide utility functions to the agents. The institution will have an account which is set to 0, and then the idea is the agents that are registered against the institution will contribute to that, and then you'll be able to determine how much has been contributed, and then based on that, eventually how much they actually get in return. The agents themselves are rather simple. They have to simply make a decision as to how much to contribute, and then they will get some payoff from that. So if we want to go ahead and implement this, obviously it seems perhaps rather theoretical, so we'll discuss coming up more specifics on the implementation. You'll also be able to find appropriate starter code in the mTree examples GitHub repository under the VCM folder. So one of the things you should be aware of course, is that you'll need an agent, an institution, and an environment. Additionally, you'll also need a config file, which has also been provided. So we can more or less start with the basic experiment template. In fact, that's what the VCM starter code more or less has, which we'll discuss in a moment. It has sufficient code for the MES. It'll help with the initialization, at least through the agent side. And it does have a very basic configuration that's useful in this case. So once you've gotten the starter code, the next step will be to think about the message space that you'll be seeing inside the VCM. And you want to identify all of the different messages that each component should expect, which will tell you both what they should receive and then perhaps where a message should be sent from and to. So this goes back to our earlier suggestion of really trying to focus on sequence diagrams. So this is the sequence diagram, which you should have already seen. It should be reasonably straightforward as to what's going on now, I hope. Obviously, you'll see the environment sends an initialization message to the agent. It also tells the institution to open up the public good. The institution replies back to the environment saying that it's open. And then the environment tells the agents that it's already initialized to register against the institution. The agents then go ahead and register. Once that registration process is done, the institution will send a message to the agent to request contributions. Each individual agent will then contribute. Once you get to complete participation with the agents, the institution will be able to report back to the agents what the final good was. Then the institution will be able to forward that to the environment. The environment will then be able to announce back to the agents what the conclusion was. The environment will then tell the institution to close the public good. And finally, the institution will tell the agents to go ahead and unregister against themselves. So one of the things to consider on a couple of these that you should just be aware of is, for example, on line 1, line 4, and line 6, you're sending from a particular component but to multiple agents, right? So it is one line, but you are in fact sending to multiple agents. So at least on those, the expectation should be that you have a for loop or something to loop through the agents to alert them to start to reply back. Then when you look at, for example, on line 5 and line 7, on line 5, the agents will register against the institution. So the institution needs to have some internal state that records which agents are there. So this presumably, because there'll be more than one, you might want to consider, for example, a list type structure or something like that. And then finally on line 7, when you have the contributions from the agents, what you're going to want to do is have something that the institution can be sensitive to the fact that all of the agents have contributed. So normally what we do is we'll take, for example, the length of the array of agents, right? So if there's 5 agents, you'll have an array of length 5, and then you'll use that variable and count down for each message coming in with a contribution. You'll say, number of contributions from agents, starts at 5, and then after each one you decrement that. Once it goes to 0, right, meaning that all of the agents have contributed, what you'll then find is that that you should actually, conclude the institution sort of waiting for these contributions, and that's when you move to the report G. So you change state. So that's how we would suggest thinking about that. At the directives that you should be prepared to handle, we'll go through the components quickly just as a guide. So the environment, we would argue, needs to handle at least 2 directives. The public good is ready, and the compute the return. So you'd want to go back and look and see who's sending those messages into the environment, which should be the institution, right? So you'll want to create message handlers for those, or directive handlers for those. So you could kind of just start by stubbing out 2 methods inside of the class with directive names that won't be mistaken. And then one thing you need to think about is that the environment needs to be able to send messages to agents and institutions. So in the agents, it needs to initialize, tells the agents to initialize, for example, set their endowment, register in the institution, and then it needs to also tell the agents what the final value is. Further, it needs to be able to send to the institution to open the public good and to close the public good. So there should be a couple functions somewhere in there where you're sending messages, right? So that should happen as well. So if we're looking at the institution's message directive that it should handle, so it should handle at least 4 open public good, agent register, record agent contribution, and close public good. And then the institution will be able to send messages to the environment and to the agents. To the agent, it tells them to register contributions, report good, back, unregister the good at the end of the experiment. To the environment, it will send public good is ready, and it will also ask for it to compute the total return. So one of the things to consider here is in some of these directives that the institution should handle, you should get some interesting behavior. So agent register and record agent contribution, that's where you need to think of the internal state of the institution. So you'd want to have set up, something along the lines of like self.agents in the init method so that you can record the agents that have registered against the institution. And then when you're recording the agent contribution, again, you just have some kind of class variable just to decrement as the agents submit their contribution. Finally, you'll want to look at the agent message directives. So you would need at least 6 directive handlers for the agent. So to initialize, register at the institution, request a contribution, report the good, and then have an announcement from the environment and also an unregistered request. So with these, for example, initialize, you'll want to think about this is a message that comes from the environment, and that's going to tell you what the agent, what their endowment is, and so that you'll need to have some property set in the init method to allow the agent to know what their endowment is at that point. Additionally, with the institution, you'll need to simply register with the institution. So in some sense, right, this doesn't actually require state management inside the agent because the agent will be simply telling the institution, hey, I'm here, this is where you can find me. So that's that. One of the things to consider is in request contribution, so that's a message that will be coming from the institution, and so the agent will need to calculate how much money to turn over. So you might think of, for example, if you have different utility functions, you might actually have a single directive handler, of course, but then you might have different other methods that you thrown out to calculate based on whatever utility function you're using. So additionally, the agent has a couple of messages it needs to send to the environment and institution. In this case, it's more the institution that it will be sending to, of course. So to the institution, it'll need to say what its contributions are and also to register. So if you think about it, for example, looking at the directives it handles, when it gets the message from the environment to register with the institution, that directive handler should, by the end of it, be sending a message to the institution. So that's where you should kind of intend to put that. But then also on the contributions, right? So when you get the request contribution directive from the institution, by the end of that method call, there should be a message being generated and sent back to the institution. So what are some starting points for this? So obviously, an easy way to start, or what we would recommend based on your current state of learning in mTree, is you want to start the construction of the directive handlers in the order they appear in the sequence diagram. This can generally help because it can make it easier to start to debug the code until you're kind of more confident in your understanding of how mTree does things. So the idea would be to start with the environment to agent messages to initialize. And further, you should see that there are a lot of parallels between this code and then some of the code in the basic example we discussed the other day. So, you feel free to reuse some of those code ideas. Obviously, some of those will be needed. You'll need to change some of them, but it shouldn't be too problematic. Okay, so that's kind of it in a nutshell. We'll briefly give a tour of the code here now, and then we can... So if you're looking at the code provided in mTree examples, you should see the VCM starter code, and you'll notice in the VCM starter code that you do have a basic config file, and then you also have an agent, an environment, and an institution. So we'll go over the config quickly. So this is a basic configuration. We won't be passing too many parameters into it today. We'll go over that tomorrow. In this instance, you simply specify obviously environment, institution, and agent, the VCM environment, VCM institution, and VCM agent. In this case, there's 5 agents. You could change out this number obviously to whatever you wanted, 1 or 10. If you wanted to keep things simple, for example, for debugging, you might want to change the number of agents to 1 to start. I wouldn't necessarily recommend that for some of the directive handling, but it would certainly be something you could do. From the environment, for the VCM, what you should notice is that there's a couple pieces that are still there. One of the things that you'll notice, of course, is the init doesn't have anything specified. So if you do need to manage state, right, you need to start thinking about how you're going to use the initialization. And then the start environment message, comes from outside from the configuration. So what you can do from that is generally you don't want to remove that directive handler simply because that it assumes that it's getting a message from the system itself. And so what you're going to do here is invoke other methods to initialize agents and institutions, perhaps. So in this case, we've preserved some of the code from an earlier example, self-initialized agents. And so what this will simply do is, since the environment, it gets kind of pre-packed with knowledge of what agents are out there, it will then go and allow you in initialize agents to iterate across all of the agents and send them a message. In this case, we've set up the code so that you can send the agents a message, but you'll need to obviously target the directive that you want them to handle and then also specify payload. So in this case, for example, you'd want to tell them presumably to set up their endowment and tell them what the endowment amount is. So that's what you'd want to consider there. We'll jump to the agent. So in this case, right, there isn't really much going on. We've preserved some of the code from previously, although it should perhaps be deleted, which will give it information of the endowment institution and the item for bidding. Obviously, there's no item for bidding here, so some of this, of course, you can delete. The init agent directive handler obviously is going to do whatever you want it to do, depending upon how you want to handle messages from the environment. So you could delete it and rewrite it as something different, because again, we haven't specified the directive that's coming in from the environment. So you'll want to consider that. And then again, you need to think through the other directive handling that you have to do inside the agent. So again, one easy way to do things would be to simply write out methods for all of the directives that you'll handle, and then simply put log messages in. Notice logs are not necessarily prints. Print statements aren't guaranteed to display. So generally you want to try to rely on the logging system as much as you can, which you'll recall from the earlier discussion in the previous code. So for example, just to be clear, you would want to use logging.log experiment and then whatever your log statement, and then anything that you put there is guaranteed to show up in the mTree.log file. So anyway, so inside the agent you'll want to, obviously add additional directive handlers, and then you can kind of slowly build them up and get them to handle everything. Finally, in the institution, again, same concept. It's a stripped down component, so you can do anything you want with it. So with this, you could simply write all the methods to handle all of the possible directives and then think about managing state. So you'll be going back and forth a little bit between directive handling and state management. It shouldn't be particularly complicated, but again, you'll want to think through it. So at this point, that's the code that we provided as a starter for this project. We will be providing you with reference code late this week, early next week, to compare whatever you've written with, and we'll give a tour of that code so you can at that point compare and see perhaps how you differ from it. So it'll be in a separate directory. Inside of this, there'll be a separate screencast going over things, and then we will attempt to compile any questions or comments or issues that people encounter, and also discuss those in a future screencast. Presumably that would be airing on Monday. Thanks.